Hello, welcome to Rambling about IEB Paper 2, May 2025. Question 7a. I don't usually do reduction questions, but I guess I was in the mood when I selected these questions, so let's do it. Right, so we've got here this jumbo term, something times something or divided by something times something. We're asked to simplify to a single trig ratio, so it's going to be sine beta or negative cos 2 beta, something like that. All right, and we do that by looking at each of these in turn and applying a reduction formula to it. Right now we've got the angles 90 minus beta, negative beta, 360 minus beta, minus 180 minus beta, all different angles, but they all share this beta in common. So if we can express all of them as ratios of beta, that will help us to simplify the expression, because right now we can't cancel anything, right, because they're not talking about the same angle. Right, so let us eat the elephant one at a time, one bit at a time. Sine of 90 minus beta, so this is our co-ratios. This is the same as cos beta. Sine of negative beta is the same as negative sine beta. Cos of 360 minus beta is the same as positive cos beta. How do I know these things? On the one hand, it's a bit of memorizing. On the other hand, it's also cost. Right, so 90 minus beta, assuming that beta is acute, that's the easiest way to remember reductions. However, the reductions apply even when beta is not acute, just as a side note. So sine of 90 minus 100 is the same as cos of 100. You could literally work that out on a calculator and see that that is true. But for the sake of remembering the reductions, it's always easier to remember them by assuming that beta is acute. So 90 minus b is in this quadrant, so we know that the sine ratio of that angle would be positive, meaning that it's equal to positive cos beta. Sine of negative beta, again negative beta, if beta is acute, would be in this quadrant, so then we know that the sine value will be negative, so it will be the same as negative sine beta. 360 minus beta also would land up in here, and we know that cos is positive here, so cos of 360 minus beta would be the same as cos beta. Right, but ultimately it is just a memorizing game. It's just about, what tools do you use to memorize the blah blah. Right, tan of minus 180 minus beta is a bit of an interesting one. So it's not one of the standard reduction formulae that we learn. So we're going to need to, there's a couple of ways that we can go about this. I'm going to do this kind of the way that I was taught in high school, when I just kind of learned trig by rote. But then I'm also going to do it a different way. And I've tried to explain the different way before in other videos, and I feel like I never do a good job of it. So this time is probably not going to be very different, but hopefully it will be like 2% of a better explanation than before. Right, so the way that I learned how to approach a reduction like this would be to say, okay, maybe I factor out the negative 1 so that this becomes 180 plus beta, right? And 180 plus beta, we know the reductions for that. So there's a two-step here. First, we're going to use the fact that tan of negative a is equal to negative tan a. So in this case, our a would be 180 plus beta. So this would be the same as negative tan 180 plus beta. Okay, and 180 plus beta is in the third quadrant. Tan is positive there, so this is just then the same as negative tan beta, right? So negative, this is tan beta, and then the negative makes this whole thing negative, right? So that would be one way to arrive at the answer. The other way to arrive at an answer okay, is to remember what are these ratios? What do they mean? Right? So if we think about the angle beta, and again, for simplicity's sake, we'll just think of it as some acute angle, right? And right, let's just suppose we draw this angle with an arm of length r, and the arm ends at coordinates x, y, right? When we say that tan beta is equal to y over x, what we are saying is that actually, no matter how long we make this arm, so no matter where it ends, no matter how long r is, you know, this ratio is constant for this particular angle beta, right? And then what we then proceeded to discover is that if I kind of look at this as a triangle whose one side is y units and the other one is x units, if I reflect this triangle in the y-axis, I then end up with this triangle. Okay, this angle is still beta, of course. This length is still x units, and this length is still y units, right? And of course, this r, I mean, we don't really care about r right now because we're talking about tan, and tan is just concerned with y and x, but for the sake of completion. So the coordinates of this point now are now negative x and y after that reflection, right? And so if we then think about this angle, right, what is the size of this angle? The size of this angle is 180 degrees minus beta, right? 180 would be this full thing, and then we're minusing this little piece over here. And what we can then see from our diagram is that the tan ratio of this angle, 180 minus b, is equal to y over negative x, right? Which is the same as negative y over x, which is the same as negative tan beta, right? Because tan beta is y over x. So the tan ratio of 180 minus beta is minus 10 beta, minus tan beta. So that's the relationship between the tan ratio of this angle and the tan ratio of this angle. Okay, that's where that reduction comes from. So if we try to think about this the same way, except now we want to think about this angle, minus 180 minus beta. So we want to see what is the relationship between the tan ratio of beta and the tan ratio of this angle, minus 180 minus beta. So let's draw again our beautiful beta. Okay, whoa, that just looks like a bee. Right, who has an arm of length r, and the arm stops at the point xy. Then let's try figure out where is the angle minus 180 minus beta. Where on the Cartesian plane is this angle? Minus 180, so remember we always measure our angles starting from here. Positive goes this way, negative goes clockwise. So minus 180 would be this bit, and then we minus another beta. Okay, so this is actually this angle. Funny enough, it ends up in the same position as the angle we were looking at before, right? These are in exactly the same position. Anyway, so we can already kind of see that the tan ratio of this guy is going to be the same as that. But anyway, let's go through this methodically. So this angle is the angle, okay, maybe I'll do it this way, that this whole thing is the angle minus 180 minus beta, right? Where this chunk over here is the minus 180, and then this chunk over here is minus beta. And more specifically, what we are more concerned with is that the size of this, we don't really care about the direction at this point. The size of this little bit over here is beta. Okay, maybe that's a bit dark. Right. And so what we then know is that this triangle over here is a reflection of this triangle over here, right? Because they both have the beta angle over there, and so therefore the same way that this length is x, this length is also x, this length is y, this length is also y, and so the coordinates over here are minus x and y. And so therefore tan of negative 180 minus beta would be equal to y over negative x, which is just the same as negative y over x, which is indeed the same as negative tan beta. So it's just coincidental that, you know, I just so happened to do this as the first example. And then, you know, this one ended up being the exact same thing. But I was trying to demonstrate how we think about the trig ratios kind of in a geometrical way, and using the fundamental definitions of the trig ratios. Sine of an angle is the ratio between y coordinate and r. Cos of an angle is the ratio between x coordinate and r. So when you're trying to find the sine ratio or the cos ratio or the tan ratio of an angle, what you're trying to figure out is, if you were to draw this diagram for whatever angle you're investigating, what would the coordinates of this point over here be, and then use that in the fundamental definitions. Yeah, that was my second bash. I tried to explain this. So in the same vein, for example, if we were to look at the same angle, minus 180 minus b, sine of minus 180 minus beta would be this coordinate over r, y over r, which is exactly the same as the sine ratio of beta, y over r. So sine of minus 180 minus beta is equal to sine of beta. Can you guess what the relationship between their cosine ratios is? So the cosine ratio of minus 180 minus beta is minus x over r. The cosine ratio of beta is x over r. So that means that the cosine ratio of this angle is equal to the negative of the cosine of this angle over here, beta. Okay, anyway, that was my valiant attempt, 10th, millionth, bazillion, jillion attempt at explaining trigonometry in a more robust way, or what feels like a more robust way to me at least. There's a guy on YouTube whose name I keep forgetting, but he introduced this way of thinking about trigonometry to me, and I think if you just Google circulometry, so circulometry, if you look for that on YouTube, you'll probably find him. But this really changed the way that I think about trigonometry and made these things just feel less foreign to me. Anyway, so we now have the first guy is the same as cos beta. The second guy is the same as negative sine beta. I'm just reading these from here, by the way. And then this guy is cos beta. And finally, we have negative tan beta. Okay, and because we have one term at the top, one term at the bottom, right? This is just something times something, something times something. We're not adding and subtracting, so we can cancel, right? There's a common cos beta. And then over here, I'm thinking I'm going to rewrite the tan as sine over cos and see if we can get an opportunity to cancel. So this is, okay, so we know that the negatives also in a way cancel, so we don't really need to carry on with them, right? Negative over negative is positive, so right. So this is then the same as sine beta divided by sine beta over cos beta, and when we divide by a fraction, that's just the same as timesing by the reciprocal. So I'm going to then actually rewrite this guy as sine beta over 1, just to make it clearer what's about to go down. Right, so we can cross cancel. We have a sine beta and a sine beta here, right? Sine beta, sine beta. So all that we are left with after all of that drama is cos beta. And of course the nice thing is you can take any beta, obviously one that wouldn't make this undefined. I'm just going to go for beta equal to 10. And if I say sine of 90 minus 10 times sine of negative 10 divided by cos of 360 minus 10 times tan of negative 180 minus 10. So that gives me some answer, 0.984 blah blah blah. That should be the same as cos of 10. And indeed I do get the same answer. So that kind of gives me some confidence that, okay, I seem to have simplified it right. So yeah, we can end it at that. Thank you for joining this exercise, and see you another time for another ramble.